I'm working on it. I promise you I am slowly learning your names, but slowly. Your last name's sweet, so I've never heard praise. Here's what heritage is. Alright, so today we're in 1, 2, 4. And just like yesterday, I want to be as hands-off as possible. So, was there anything from yesterday that like really needed wrapped up? Anything from the homework that people like really have questions on? Is there anything we need to go over before we start 1, 2, 4? So we had homework questions about marbles. We've got amusement park. Anybody have big issues from the homework last night we want to ask about right now? Yeah. Homework board. So always can check the homework board to catch up your plan book. And then I'll ask for issues again. I will not be here tomorrow. I need you guys to be aware of this. I will be out observing exemplary teachers in the district. So either Mr. Scherg or Mrs. Cullinan is going to be your math teacher tomorrow. So I'm going to leave them sub-plans. They're going to act as if they're my substitute. But I will not be here. I'll be out of the building observing other teachers. So we need to, in your math, well, actually, flip to 1, 2, 4 in your book. So we're right here. And then in your math journal, in your math toolkit, we want to look, do we have a place for this to go? If you notice, if you flip to page 12 of your toolkit, you get more learning log pages for chapter 2. And again, I'm learning this as you guys learn this. So if you want these learning log pages in the front, if you date well and you put the lessons well, you can use those learning logs in the front to carry on your notes. So because we're trying to use the toolkit for notes, let's go ahead and flip to page 2, because I think most of us filled up the page yesterday with notes. So I'll turn on my little camera so we're all doing the same thing at the same time. Flip to page 2 now, since this is still chapter 1, and it's headed at the very top, Introduction and Probability. So let's use this page for our notes today. So over here with date and lesson, we're going to go ahead and fill in today's date is 9/7, and you can put the year if you want. And then the lesson is 1.2.4. And the lesson title is Expressing Fractions as Percents. Really, I'm just going to put fractions as percents. You can put expressing if you want, but I know a lot of you want to write as little as possible. Make a little fancy underline if you want. Now I'm going to toggle over to my smartboard notes because it's a lot easier for you guys to see if I'm working on my smartboard. But we all want to be taking notes in our toolkit. So our first question is 185. Please number your first question 185 as we're all getting used to numbering and keeping all this straight. So we had today was 9/7, 1, 2, 4, and 1. What's the question for 85? Have at it. I don't want to say anything about this. I want you guys to just dive in, start reading as your team rolls. Decide, do we want to read this out loud? Do we want to read this quietly? How are you going to approach the problem? Mr. Smith and I will filter around the room and help you if you need, but we'll probably just observe. All right, so hold on. I see everyone diving into 185. I guess we should really quickly, and I'll just read this since we're just going to read it. So let's check out the paragraph above 185. So in the last few lessons, you've been working with fractions and percents to represent probabilities. In this lesson, you will use geometric strategies to further your understandings of how to convert fractions to percents and to model that conversion. Learning the geometric strategies will give you a deeper conceptual knowledge and connections between these different representations of portions. Some of us haven't ever been explained the difference between algebra and geometry. The simplest I can tell it to you, geometry is when we see it, draw it, model it. Algebra is when we numerically calculate, work with the numbers. So that's the difference between algebra and geometry. If you are more of an artistic type person, you'll probably sway towards the geometric side. If you're more of an analytical type person, you'll probably sway towards preferencing the algebra side. They go hand in hand. So if you're stronger in algebra, you make up for your weaknesses in geometry. If you're stronger in geometry, you can make up for your weaknesses in algebra. So sorry, I wanted to get us centered and talk about that. So when they show you a model, that's geometric. So when they show you those boxes and all that stuff, that's geometric representation. All right, now dive into 185. Which actually is funny. Check this out. Skip. Accelerated class. Literally jump right through. Because it's all factored transfer random fractions and fractions. And this is where the jump.
Short answer.
What do you mean reading it wrong? Oh, you would go to CC3 or something? Yeah, I think that was. We did that at training. Oh, yeah. You know what? I look at lessons and say, oh, good. Oh, there's no materials. Because this first year, 3 materials for us. Oh, I was last year. I was so far ahead last year. Well, last year was my second year of not using digits. I'm using problematic to make tests. So I was just doing all modifications. I like what I'm hearing. I'm trying to keep my distance, but I like what I'm hearing, guys. So let me ask the question the other way. What would be half? So could you get half of the first two heads or tails? No, not with 25. Mine doesn't stay up anymore. Good stuff, guys. I think we need to do this with all groups. I think they can work. We're talking about moving desks. But not moving people. So you mean like this direction kind of? Turn sideways. I almost 20 was 26. Reminder, Mr. Smith and I are just kind of like chatting and observing whatever. If you get through the entire lesson, the time is yours, so you can work on your homework. So just reminder, stay focused, stay moving. If you get through the lesson,
We have to do the review.
That is fine. So if we get through these 2 pages, then you can just continue on to the next one. So switch to your journal.
Yeah.
so I think at this point most of us are through 85, just from my walking around and observing. So let me get our cards out. I'm going to try to section these out so that I can also just call them like group specifics. Who's in this class? Is Francesca in this class? Yes, so this is your stack. Sorry, last year I had them color coded. I'm getting used to this year. So let's choose randomly. So Zoe. Help me out. Where's Zoe? Zoe. Nice to put a face with me. I'm trying to learn your guys' names. I'm sorry. What about A from your group? We have 14 heads out of 25 flips, and we were asked, is this more or less than 50? How'd your group approach that?
First of all, we said it was more than 50%, but we tried to figure out what half of 25 was. 25 wasn't, it was 12.5.
Ah, so you guys took the route where you said, okay, 50% would be 12.5 flips. Because that's, how'd you do that? How else can we look at 50%? Alex? It's a half, right? So we can divide by 2. So once you knew that 50% was 12.5, it was pretty easy to say 14 is bigger than that, right? And then you guys got your answer that it's more. So with B, Matt, what about, did you guys have a different way? I don't want to like give away what we're trying to get to. So forget that. Did anybody solve this in a way that you think is like really good, like a different way than thinking about half of 50? I know this group had talked about a different way. You specifically, do you want me to say it or will you say it for us?
Do you mean for 185A?
Yeah, when you were talking about like 14 and 14.
Yeah, 14 plus 14 equals 28. So if they're asking for 50%, it would have to be 12.5.
So that route of saying if 14 is 50%, let's play out the if for a minute. Then the total would have to be double and be 28. So that was a great way to say the total's not 28, it's 25. That 14 must be more than the 50%. Keep rolling. I think most of us are on at 186 now.
Lamar also kept track of the number of heads he put. He wrote an experimental probability of flipping heads at the fraction 7/20.
We are going to check B. Sorry, if you're concerned about why I skipped, we are going to come back to it. But keep working on 86 for now.
He wants to rewrite 7/28%. To do so, he knows that he needs to rewrite it as a portion of 100. He started by drawing a picture at right front at 7/20. A. After looking at his picture, Lamar realized that he could adjust his drawing to show 100 parts instead of 20. Lamar then drew a new diagram below his original picture. How many of the 100 parts are shaded? Explain the reasoning.
Alright, try to calculate 14%.
Please read the stoplight box when you get there. Please read the stoplight box when you get there. All right, really quickly, and you can ignore me if you want. We're going to go over 85B. Seriously, you can ignore me if you want. Grant, I looked on your notes, and they look pretty good. How did you go from 14 out of 25 to a percent?
I multiplied by 4.
Why? What was your goal?
Because I noticed, well, we all noticed that the denominator, if I multiplied 25 by 4, I would get 100.
And you know percent means out of 100. So literally, if we can make the fraction have 100, this number's your percent. So Grant said he multiplied by, class, how much? 4. We do that on top, what do you get? 56. So we should have that Lorianne, or whoever her name is, had heads 56% of the time. Please check that on your paper. If you get done with 86 and you get on to 87, please read the stoplight box. Keep going. Oh, sorry, I'll scroll back up. Mm-hmm. So, like, I have a pair of arrows going from bottom to bottom and top to top. I would see just because it confuses your brain away. You don't have to, it's my suggestion.
but it has to be area compared.
Wow.
Well, probably by the student. Here, what you can do is
Well, I mean, Beth or Adam. Sorry, it's but you don't have anything over. But there's not many homeless.
I think just writing this, like, would you like, I wrote, rational numeracy, 40 over 100.
Not 5 by 5, right?
Arrows times 2.
That is interesting visually taking that and making 4 of them. So you made 2 5 by 5 into a 10 by 10.
Not changing it. It's pretty nice handwriting. My best handwriting happens when I'm not.
Because I still got kids in the day, so tomorrow's bonus option is not crazy, so I should be able to figure that out.
Let's bring it together really quick to talk about 186. I hear a lot of us either wrapping that one up or moved on to 187. So, Emily, your card came up next. When you looked at this, we have 7/20ths to start, and then he starts by drawing this picture, right? Then it says he realizes he can adjust his drawing to show 100 parts instead of 20. So, how did you guys work through this? Did you write anything down mathematically to show what he did? What did your group do? Because then in C, really the question is in C, how do we use these skills to convert 3/10 into a percent? Are you more geometric or algebraic, do you think? Do you like the pictures or the math? The math. So if we start with 7/20ths, what is our end goal? What do we want? Ooh, well, I don't know that I want that. But I do know that I want a percent, right? I don't know how much percent, but I want a percent. And we know percent is, what's it mean? Out of 100, portion of 100. So, what does my denominator need to be? How do I get there? We multiply by 5. I advise showing these arrows in your notes to help cue your brain into what you're doing. And like you then said, we get 35%, which if I count all these right here, I get 35. If you are the geometrically minded person and you didn't pick up on this, what they did was they subdivided all of these blocks and made them each worth 5. So now we have 35. And then they chopped them up. So instead of each being worth 5, they made them 1s, But instead of keeping the 5s all together, like that last 5, they spaced them out so that you could see 7 out of 20, but then it happens 5 times, which is when we multiply by 5. So if you're more geometric, that's what they did. They showed if I chop this, really they realized I got to chop it into fifths. So I'm multiplying by 5. I'm making 5 times the pieces that I had before. So, Emily, I'll quit picking on you. Marvin, if we look at 3/10, we start with 3/10. What do I want my denominator to turn into? 100. How can I get there? Times 10, which makes my numerator. 30, which makes my percent value. Yeah, just 30%. All right, keep rolling on 87. Please pay attention. That stoplight clues you into mistakes people normally make. So it is telling you the route to avoid. It's saying don't go down this rabbit hole. This is where we formalize that what we're doing is actually multiplying. Be here for that. There's something like really cheesy and making a joint. I literally thought of cutting out those whiteboards, like write a number of the number inside of it. I have a shooting camera lesson. I have a bandsaw in that course. I can totally do that. Except that'll probably Are you talking about like cross reducing? Well, I hate, and I do this myself, I'm not getting really good. And that's what we as math teachers quit saying, like elementary math, like how do we cancel out or things like that. Now how do we reduce or simplify?
For some reason, the last question was always repeated, but the one that you are
Basically what they do with the giant backtrack data with the old-fashioned.
All right, Aubrey, your card is next up on our pile of fun. So, how does 20/50ths compare to 50%? What route did you guys take? But I heard, like, I literally just heard, like, as far as you needed to be. You just got there. I heard it. By what? So, if he did this 50 times, and we have 20 out of 50, 20 out of 50, or 20 50ths, sorry, I didn't want to say it like 3 different ways. Aubrey's identifying, we could easily have a percent value, I like this shade of green, if we did it 100 times. I can find percents if I do anything 100 times, because it's out of 100. Now, he doesn't actually want to do it out of 100. So instead, we just anticipate the same thing would happen again, and they doubled there, so we double here. And the last thing they said that allowed me to call on Aubrey was I heard them say 40%. So Randy actually had that happen 40% of the time, which he's really lucky. Because when you do that 2 things at the same time, we'll talk about combined probability later. But this is actually higher than what we would anticipate. Who can talk about the stoplight part? I might take a volunteer for that if anybody really understands. What's the issue with what Randy tried to do? He says that 20 50ths is equal to 70 hundredths because you can just add 50 to both of them. If I want to get 50 to 100, I can just add 50, right? Patrick?
No.
What's up with that?
If you wanted to add fractions, the denominator would need to be the same number, and to get to 100, you need to whatever you do to the because you need to multiply to get there. Because even if you hold on.
So this is what he said, right?
Yeah.
You know it's wrong. Now, one way we can approach this, we simplified or rewrote 20 50ths. We know what it is. 70 over 100 would be 70%. Is 20 50ths over half? No, we know it's less than half. 25 would be half. So we see this fall apart if we think critically. You gotta have your brain turned on. I've made this mistake. All of you will at some point probably make this mistake. If your brain is turned on and engaged, you'll see, wait a minute, that doesn't make sense. I cannot do this. The only thing I'm allowed to do with my fractions to manipulate it, what operations? Multiplication and division. And really, division is the same thing as multiplication. So we could say, and I'd love you to write in your notes, we can only multiply with my fractions to modify them. We can only multiply to modify. All we want to do is change what it looks like. We're not changing what it is. We're just changing what it looks like. Patrick?
I realized 20 can't go into 70.
Who what?
20 can't go into 70 if you multiply it.
Yeah, that wouldn't work at, like, that totally falls apart. This is absolutely not right. On that note, that's it for today. Please make it an easy day for whoever's teaching my class tomorrow. Please just be your awesome selves, because I know you guys have been doing great, by the way. Let me just give you a pat on the back. Like, you're doing awesome with the teamwork stuff, with working with each other, processing through these things. So I'm going to try to make your class easy for tomorrow, but you got to, like, help make it easy for that teacher, whoever it is. And if it's Mr. Sherry, you got to be really nice to him. Because, you know, he's a principal trying to teach math.
I don't know how I wanted to say that, so just kind of went with it. That was, you couldn't tell.
Hmm? Yeah, it's probably going to be interesting.
Yeah.
I think he was excited to actually, like, potentially get back in the classroom. Because I really feel like once those guys go into administration, they, like,